Hey everyone, so welcome to this video. So in this video, today I'm gonna share with you some amazing Python decorators that can reduce your code by half actually. Sounds too good, right? So we'll be discussing on that end to end, so how they work and why do we need to use that in our project actually. So let's deep dive into that. Alright, so the Python decorators are powerful features that allow you to modify the behavior of the function or class without changing its source code. They are essentially functions that take another function as an argument and return a new function that wrap that original one actually. So this way you can add some extra functionality or logic to the original functions without modifying it actually. For example, I can just type hello in that function, so I can type just hello world actually. So all right, so in that function, now if I call those function, I'm getting that hello world value actually. Now suppose you want to measure how long it takes to execute this function, you could write another function that use the time module and calculate the execution time, then calls the original function actually. So in that part I'm gonna just import time module along with that. So I can type measure time. In that as an argument I can get that function, and in that I'm gonna write some wrapper function. So in that start time dot time, like that, and after that I can just again call the function, and n should be a time dot time as well. After that print in that execution time. In that and should be a start in seconds. All right, so after that I'm gonna just return that wrapper. So now notice that measure time function return another function called wrapper, so which is the modified version of the original function obviously. The wrapper function does two things. It records the start and the end time of the execution, and it's called the original function. Now to use this function you could something do like that. I'll type that. So hello equal to measure time, so which I already wrote at that hello, and in that, so I'm gonna just simply again call the function. As you can see that hello execution time, it will be taking some 5 milliseconds actually. So it's very crazy, right? So all right, as you can see that we have successfully added that some extra functionality to the hello function without changing its code. However, there is more elegant consistent way to this using decorators. Decorators are simply easy actually. So I'm gonna type actually like measure time and def hello, so same as print hello world, and after that I'm gonna type just calling that hello function. So as you can see that we already written that this function measure time, so I can just simply using as a decorators, so you can create a one single wrapper function, so automatically that decorators you can use it anywhere in that code actually, so that this would produce the same output as a before but with much less code. The measure timeline equivalent to hello equal to measure time hello, but it looks much cleaner and readable actually. All right, and the next thing is why use the Python decorators actually. So Python decorators are useful many reasons, such as they allow to use that reuse code and avoid that repetition. For example, if you have many functions that need to measure their execution time, you can simply apply the same decorator for all of them instead of writing the same code over and over again. And the second thing, they allow to separate the concerns and follow the principle of single responsibility. For example, if you have a function that performs that complex calculation, you can use a decorator to handle that logging and error handling, catching or validation of the input and output without cluttering the main logic of the function actually. So some examples of the Python decorators actually, so such as static method, class method, property, and a func tool on, and a func tool inside that multiple things will be there, LRU catchy and a single dispatch, etc., 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 like that actually. So I'll show some example with the Python decorators can reduce your code by half actually. So first I can use that timer decorator actually. So this decorator is similar to the measure time decorator we saw before it, right? But it can be applied any function that can any number of arguments returned by its any value. So it also uses that function tool. Decorators preserve that name and doc string of the original function actually. So I'll type the code, so then you will get an understand from that actually. So the first thing I can import that time, and after that from function tools obviously, in that I can import that wraps. Alright, so after that timer, in that timer I can just type function, and after that I can wrote that some wraps. So in that wraps that comes from the function tools, same as I can put it in that wraps function. So after that I can type wrapper. In that I'm gonna using that some argues technique along with that some optional argument also. Oops, my spelling mistakes. Yeah. So after that start equal to time.time, and the result should be a same as function. Along with that function, if you get any kind of arguments along with any kind of optional arguments, so we can use it over there. And the end time should be a time.time and a print. So in that print execution time as well actually, execution time of. So in that we already using that function name, so in that it will be returning that name of the, and after that name of the function, and after that end should be a start minus start. So it will be returning that how much time will it take to run this function actually. So after that I can just return that result as well. At the same time I can return that wrapper as well. Alright then, so now I can run this cell. Alright, now you can use this decorator measure the time execution of the any function, such as I can type that some example functions actually. So I can use some timer, that same as timer function, and then def, let me scroll it up, yeah, and I can just simply type that factorial program. In that factorial, so in that I can just type n if is equal to 0 or f equal to 1. If it is there, I can simply return 1. Otherwise I can return that n star factorial n minus 1 as well actually. So this is what we did actually. So at the same time, oops, I just forgot. Yeah, at the same time I'm gonna write another function that called Fibonacci, same as some simple school example. Yeah, that's why. So in that def Fibonacci, in that n, say same that if n equal to 0, and then or if n is equal to 1, if it is there then return en as well. Otherwise return Fibonacci n minus 1, same thing, plus Fibonacci n minus 2. Alright then, so now I have a 2 program with the timer decorators actually. So in that now I'm gonna type some print function factorial of 10 along with, so I have another thing, same Fibonacci of 10. Alright, so if I run that output should like this actually. So each time of Fibonacci how much will it take, and each time of factorial how much will it take actually. So this is very crazy, right? So Within the second, you can trace that each of iteration and each of the time without using the duplication code. You can simply using this timer decorator actually. So it will be reducing that your code maximum of line actually. So this one, and the next thing is the decorator actually. So this decorator is useful for debugging purpose, and it prints the name arguments and return the value of the function it wraps actually. It also uses that functool wraps and decorators to preserve the name and doc string of the original function actually. I'm gonna type some basic thing like, so first thing, same as I'm gonna using that import functools and import wraps. So after that, just debug function I'm gonna write. In the debug function I'm gonna just create the function as argument, and at the same wraps in that function I can use it as a decorator. So after that I can create some wrapper function, basic wrapper function, in that same as what we did in that timer function. Arguments, and also put that some optional arguments. Cool, right? So the next thing, I'm gonna type some print calling function. Alright, so in that in that name it argues arguments args and krgs optional argument as well. Alright, so the next thing, result should be a same as my function tool. My bad. I can just simply copy that. Alright, so the next thing, print in that from the function tool, I'm gonna take that function name and also return result as well actually. And the next thing, return result and then return same as wrapper. Now you can use this decorator to debug any function, such as I'm gonna type add, so in that returns the sum of x and y as well, and the same as I'm gonna create some another function called a greet, just sample function I can just take actually. So now after that, so I'm gonna just simply run that function, print add 2 3 and greet allies. I just calling that multiple times the same function actually. So if I run that, as you can see that calling add with an arguments 2 3 and return 5, and the same as calling a greet with allies and optional, there is no optional argument as well. And the next thing, calling greet arguments along with k arguments and greet return to hiba actually. So so this is one thing. And the next thing, we're gonna talk about that memos decorator actually. So this decorator is useful for optimizing the performance of recursive or expensive function, as it catches the results of previous calls and return that same arguments are passed again. It also uses that function tool wraps decorator to preserve the name and doc string of the original function actually. Or let me explain. So in that same as I'm gonna take that function as a wrap tools. After that I'm gonna create that memos function actually. So here is the code. So in that memos and function, under that I just create on catchy and a wraps function. So in that, if arguments in that catchy, so then we can use that same previous results of the catchy. If it is new, then we need to run the function and get the result and store in the catchy actually. So it will be saving that more and more time of the duplicate instance actually. So if the same instance is runs twice, so at that time it no need to run multiple times the same functionality. So it will be simply take the output from the catchy and it will return that actually. So here is the major thing, and now you can use this decorator that memoize in any function, such as I can create a same factorial which I previously used. So this is one factorial, and the same thing I can use that memoize thing actually, sorry, Fibonacci actually. So here's the two things. Now I'm going to call that two functions actually. So now I have a factorial and a Fibonacci. So let me run. Yeah, so we have a result actually. So now if I run that same thing on the multiple times, yeah, same things on multiple times. So first time only it will be running that logic, and the second time will it taken from the catch value, and simply it will be written that actually. So it's pretty easy, right? So this output same as before that, much faster than execution time, as a result are catched and reused actually. Or let me show some other example. Hold on. We have a timer as well actually. So I'm gonna just take that along with the memoize. So in that, if I run that, so same as, so the first execution only will it takes too much time actually. That second execution directly we get that results actually, because this execution already will run actually from 10 actually. If it is 9, then the new instance will it run. But if it is old instance, so it will be taking the catch value and directly it will be run actually. Fibonacci also the same, and so these are the Python decorators, are very powerful, and it will be very friendly to reuse actually. So in the conclusion, Python decorators are powerful and elegant to modify the behavior of the function in the classes without changing their source code actually. They help you, it's reduce your code by half and improve your code readability and reuse your code actually. And it will be separate your concern actually, and extend the functionality of the existing code. I hope you enjoyed this video and learning something new. If you have any questions or comments, please feel free and leave them in the comment section below. I'm happy to respond, and we'll see you on the next video. Thank you. Bye.